Good middle morning, everybody. Thanks for coming today. Welcome to Jot or Not, a personal exploration of insecurity in myself and in software, in particular in JSON Web Tokens. Appreciate you coming out today. It's really nice to be back on the Identiverse stage. It's been a while for a lot of us. I was actually on stage last year, but nobody came to my session, so it doesn't count. And when I mean nobody, it was bad. So I really appreciate some people in the audience here. I hope to entertain you today as much as you can be entertained by nerd things and maybe teach you a few things as well. So with that, let's get started. So Andy, the content chair of Identiverse here, always does a pretty rigorous review. And every year he tells me that I need to include an agenda slide. So I preempted him this year and actually put it in before he had a chance to review it. And in doing that, I included a picture of him from some of the past years. So here, setting some expectations for this talk, just a quick agenda. Going to do some introductions. Going to give an overview, little review, overview, depending on how you look at it, of JWT, JOT, and the Jose suite of standards. I'm going to attempt to distill some of the criticisms that have been levied at the JOT technology from a wide range of places and in various degrees of hate. And I'm going to take a closer look at some of the specifics. And ultimately, I'm going to close with some ramblings, some recommendations, maybe some reflections, and some other stuff, mostly ramblings probably. So let's get started with introductions. I am a distinguished engineer at Ping Identity. That is a fancy sounding title, and that is me trying to look fancy. I think what happened is I've been there about 18 years and they just ran out of titles to give me. So I'm not sure it's as fancy in practice as it sounds, but it's what I got. I'm sticking with it. I don't do much engineering even these days. I do a lot of standards work, occasional look at engineering, don't have a lot of time on the keyboard. I am not a lawyer or an investment advisor. So don't make any investments based on anything you see in here. It's also just to say there's a lot I don't know. And I'm definitely not a cryptographer. So while the JWT standards deal with cryptography, it's mostly an application layer construct over the top of cryptography. So I'm fairly well versed in that layer, but not in the cryptographic layer underneath it. Like I said, disclaimers, et cetera. Ian did this talk a few years back at Identiverse, and it really landed with me. There's been a lot of talk here throughout this thing about imposter syndrome and feeling like a fraud, but when I saw this bump up on stage, I was pretty sure he was talking about me. But despite feeling like or being a fraud, the bills need to be paid. So I took some advice from one of my favorite career books. This is Piggy and Gerald. Everybody pretends. So here we are. I'm pretending as best I can to know what I'm doing with this stuff. I am or was a Java developer. I know that's not cool anymore. I'm not sure if it ever was. It's kind of like the new COBOL. I've done some SAML work. It's still used a lot for a dead protocol, which I guess is good, but at least it's complicated. I was a contributor, not an author, but a contributor to the Jose and JOT suite of standards. It had the appeal of being less complicated than SAML, which was a huge appeal at the time. It really had a lot of promise and a lot of interest based on just not being SAML, XML signatures. IETF participation really felt important. It felt important to participate and contribute. They also meet in a lot of really cool places, which was a side benefit of doing some of that work. And I wanted to be a part of something. I wanted to contribute to something that looked like it was going to impact our industry moving forward, and I think arguably it has. I'm sometimes a photographer, as you've probably seen me out here running around with my camera. I mostly say that, though, because it rhymes with cryptographer, and it feels like that's maybe some street cred building. But it also explains some of the photos that are in this that are really only very tenuously related to the actual content of the presentation. I get very gratuitous with that stuff. I did an early JOT Jose implementation. I was trying to do something useful again. It seemed like a good thing to do. It's used all over the place now. It's probably the third or fourth most popular Java Jose implementation, which is not to say it's very popular, but it is used a lot. It's still not in version 1.0 because I can't seem to just get over that hump. So it's 0 dot something, something, something. But it is widely used and production ready despite my insecurities with the versioning. And I did a lot of early evangelism around the topic, trying to teach people about what it is, and just, yeah. Feeding a fragile ego was a hell of a drug. It was fun. It was fun times to talk about new technology that people were interested in, new standards, get up in front of people like this and talk about things that they were interested in and were hoping to use in the near future. But nobody likes to hear that their baby is ugly. And that brings us here. There's been a lot of criticism around the suite of standards, the way that they've been implemented and the way they've been deployed. And I felt like it was time to try to talk about it, say something meaningful about it, for better or worse, and that's what I'm trying to do here. So even my photography side hustle feels like a bit of a fraud sometimes. Here was me trying to set up some equipment a while back. Didn't go quite as planned. Anyway, let's jump to an overview of JWT. JWT and Jose, the stack's kind of laid out there. Jose is short for JavaScript Object Signing and Encryption. It's made up of a few different parts: JSON Web Signatures, JSON Web Encryption, JSON Web Key, and then the JSON Web Algorithm spec that define the first set of algorithms that could be plugged into those components. There's been some additional algorithms developed in other standards, but that was the mainline base set. And then JSON Web Token is a separate RFC that builds on top of the Jose suite of standards. JSON Web Key is a JSON data structure representing cryptographic keys and metadata about those keys. You can represent elliptic curve keys and RSA keys with or without the private portion of the key. I noted the red part there is the private key in that particular elliptic curve. On top of it is an RSA key. It's a bunch of math, numbers, base64 URL encoded and encoded in JSON. There's also symmetric key support. I noticed right before we started this that I had a typo in there and I deleted one of the parameter names, so that's not actually syntactically correct. But basically it's just an encoded symmetric key inside of, encoded in base64 and JSON. JSON Web Signature is content, any content, arbitrary payload content, secured with a digital signature or MAC using base64 URL encoding and JSON. Or it could be not secured at all because, what could possibly go wrong with that? Conceptually, it's pretty simple. You have a header, a payload, and a signature concatenated together with a period character that make up a JSON Web Signature object. The payload is, like I said, arbitrary data. Anything can go in there, but then it's base64 URL encoded, and the signature is applied over the top of that, so there's no need for any sort of canonicalization and normalization of the data. The encoding of it in base64 URL is basically that normalization. The signature is just an encoded signature or MAC, whatever the output of that operation is, encoded again and tacked on the end, or the empty string if it's unsigned. And the header is JSON, again encoded, with parameters describing the signature or MAC and maybe other stuff about the JWS object. Some of those headers are defined. There's an alg. Alg defines the algorithm that was used to sign this JWS. There's a bunch of HMAC signatures, which aren't actually signatures, but there they are. There's actually a wide variety of RSA flavors, both the older PKCS 1.5 RSA signatures and RSA PSS. There's elliptic curve digital signature algorithms using some of the NIST prime curves. There is nothing, which is the famous alg none. I'm sure we will talk about a bit more later. And it's extensible. The algorithm parameter is one way of enabling cryptographic agility, so new algorithms could be plugged in here and then implemented if both parties understand it. And there's been a few extensions that are done around EDDSA and ECDSA with a more popular curve in some of the Bitcoin type communities. So the extensibility there has been used, although in different levels of adoption with different libraries. Then there's some other headers. There's a key ID, which is just an identifier for the key that was used to apply this operation, usually helpful to the recipient to tell them what key to use to verify the signature on the object. There's a way to point to a URL in the header of the object to go get a set of keys. There's a way to include a full key as a JWK representation that would be used. You can point to a URL that has X509 certificates. You can point to a thumbprint of an X509 certificate. You can include a certificate or an entire certificate chain directly in the header. There's a type parameter that allows you to say what kind of thing this thing is, what kind of JWT this is. And there's a content type parameter, which allows you to say what the underlying inner content is, what is actually signed, what the media type content of that. And then there's a critical header, which is a kind of esoteric way to enforce certain extensions are actually applied. Probably too esoteric to go into detail here, but it is there. Quick example of a JWS. Hopefully this is high enough on the screen that only half the audience can see, but it looks like this. There's 3 different parts in the colors here. The header is this piece of base64 URL encoded JSON. It's saying ALG ES256. It's saying this thing was signed with elliptic curve digital signature with the prime P256 curve. And the kid here is you know the one, which is just to point out that the key ID can be really anything that both parties know how to interpret. So it's just a hint as to what key the verifying party should use to verify the signature on this. In this case, the actual payload is everyone pretends, going back to my career advice book, Piggy or Gerald. I cannot remember who said it, but one of them did. I get the pig and the elephant confused. But that's all it is that plain text encoded. That's what's being signed. And then the signature itself is a bunch of bits and bytes applied over that piece, the header concatenated with the payload. That is fed into the signature algorithm, and the signature is applied to the end. And that makes up the compact serialization of the JSON Web Signature object. JSON Web Encryption is similar in motivation and design to JWS, but for encrypting content. It's kind of simple, but not quite as simple as JWS. You have a header, you have potentially an encrypted key, you have an initialization vector, you have ciphertext, and you have an authentication tag. Each of these are encoded segments separated, again, by the dot character. The ciphertext is a base URL encoded encrypted arbitrary data. Again, any plain text arbitrary data can go in here, even though it's JSON this, JSON that. The actual payload of these objects can be anything. The authentication tag is the encoded AEAD output for the integrity of the ciphertext and the header as additional authenticated data. That's just to say that all of the symmetric encryption that's performed in JWE is some form of authenticated encryption. So there's an integrity check in addition to the encryption portion of it, either built into the algorithm itself or applied on top of it by constructs within JWE. It's all authenticated symmetric encryption, and the tag is the integrity portion of that. There's an initialization vector, which is fed into most, actually all of the symmetric ciphers. And then there's an encrypted key in cases where there's some sort of key management algorithm happening at the top layer, like a RSA, encrypting an encrypted key to be used to encrypt the content. That would be included in this piece. And then their header itself, which is, again, is very similar to JWS. It just is used to describe this object. It's a JSON, set of JSON with parameters describing the encryption that happened, and maybe some other stuff about the JWE. The ALG parameter describes the algorithm that was used to encrypt or determine the value of the content encryption key. So there's RSA, old-fashioned RSA, RSA OAP. There's ECDH, ephemeral static, which is a key agreement. You can, with those same NIST prime curve, they can be used with and without an AES key wrap step. There's regular AES key wrap. There's AES GCM key encryption. There's a direct encryption mode where the key itself is used directly as a contract encryption key. There's password-based encryption with AES key wrap. and extensible in the same way by using the alg here, although it turns out that the way that newer algorithms have been added on have come out in a little bit different way. They've actually fell underneath the construct of the elliptic curve Diffie-Hellman rather than defining new algorithms. It's worth noting here, though, that this alg indicates the encryption mode for the whole object, and there are asymmetric and symmetric variants included in this alg, which have very different properties. So you can define, the same JWT object can be asymmetric or symmetric just by toggling the value of the alg parameter itself. And then there's ENC, which is the content encryption method. Like I said before, these are authenticated encryption only, and these are a little bit more straightforward. There's AES GCM, which is itself, by its very nature, authenticated encryption, and then there's an AES CBC with HMAC SHA-2 composite mode that CBC is not an authenticated encryption, but the way that the constructs in JWT work, it uses HMAC as well to build an appropriate authenticated encryption mechanism using what were at the time widely available crypto primitives. GCM is a little bit more widely available now, but when this stuff was originally developed, it wasn't available on a lot of platforms. So JWT offered an encryption method that was authenticated by constructing and using widely available lower level primitives. There's a compression algorithm if you want to compress the plain text before encryption. It's optional. And then there's the same key identification headers as in JWS. Some of them don't make a lot of sense in this context. Some of them do, but it's the same idea of sort of telling the other party what key needs to be used for the decryption process or key negotiation process. One of these things, or some of these things look like this. This one is a elliptic curve, Diffie-Hellman based JWT with the composite CBC HMAC content encryption. Maybe the only thing that's notable out here is because it's a Diffie-Hellman algorithm, there is an ephemeral public key encoded as a JWK in the header itself, and that's used for negotiating the key that's ultimately used to do the symmetric encryption of the content, which itself is the green portion under there. I won't show you the insides any of the rest of that because it's all either binary encrypted data. This one is RSA OAP. Excuse me, no one will be able to see that. This mode works by generating a random encryption key, encrypting it with the receiving party's public key, and then including that, this yellow part, as the encrypted key in the body of the content, and using the key itself unencrypted to encrypt the actual content itself. In the green, and then there's an IV in there, and the tag on the end. It gets complicated. And no one can see this, but this is a symmetric mode that's just saying this is direct encryption using a symmetric encryption key encoded the same way. Then there is RFC 7519, which is JSON Web Token itself, which is probably the best known and most popular piece of this. It's what most people know about, even though most of the work is done in the the Jose underlying layers. JWT builds on top of that and is what's most widely used by most people, developers and people in our industry. The suggested pronunciation, and this is right out of the RFC itself, of JWT is the same as the English word JWT. I still have trouble and go back and forth saying JWT and JWT, but it's nice because it enables bad wordplay and rhyming jokes like the title of this here presentation. Hot or not website and JWT or not for the presentation. It's a much criticized website, but in a lot of ways, it sort of was an early precursor to a lot of the social web that we see today, for better or worse. Anyway, JWT or JWT. A JWT itself is a JWS or a JW and or a JWE with JSON as the payload. JSON claims as the payload inside it. That's really the only thing above it that's any different. It's just the payload of it is this JSON that has certain semantics. A claim is a piece of information asserted about a subject or about the JWT itself, sometimes other things. A few of the predefined or well-known claims are an issuer, who created it, a subject, who it's about, an audience, whom or the JWT is actually for, an expiration time, a time before which it's not valid, time it was issued, a unique identifier for the token, and the claims themselves are extensible and widely extended. They get, a lot of people use their own claims. There's a lot of new claims that have been defined. You can pretty much put whatever you want in the JSON claims. Again, no one will see this, but here's a jot. It's saying that this was signed with elliptic curve, and the key ID is known as number 5. The signature's at the end, and then the payload here is just some JSON saying IDP example issued this. It's intended for rp.example, expires at this Unix epoch timestamp. Here's an identifier for it. The name of the subject here is Brian Campbell, and the sub itself is bdc@example.com. So it's just some identity information or attribute information encoded in JSON and signed over the top with JWS. Somewhat allowed for in those layers, but sort of codified in OpenID Connect was a way to do key publication and rotation in a pattern where a set of keys in JWK format are published at an HTTPS URI, and then maybe potentially rotated or moved over, but they're published there. And then the header of the JWT includes a key identifier that maps back to one of the public keys hosted on the HTTPS JWKS endpoint. And that's a way for the receiving party to dynamically figure out the signing keys for the particular party that's provided. There has to be some stuff that's changed out of band, particularly the endpoint URL. But it helped to address a problem of key rollover that was really problematic for SAML deployments. This was a more dynamic way to do it.
And Brian invented that.
I did. I was just going to say that. I wrote the text for this. I didn't invent it. I borrowed the pattern from other people's ideas and codify it in the OpenID specs by writing the text for it. But I want to assure you that OIDF standards work is not as glamorous as it might seem. This is a red carpet welcome at an OpenID Foundation meeting circa 2012 or 13. I don't remember exactly, but really, really warm welcome they had at that particular meeting. So back in 2014, I was out spreading the good word of Jose. I think some of these are actually at an Identiverse conference itself, and I was even wearing a shirt that was, what would Jose do? Even my boss's boss's boss was repping Jose. So it was popular. People were interested in it. And some things I was saying about it at the time are, it's widely used. It is widely used. It was widely used then. It's probably even more widely used now, and not only in the intended context that we thought it would be used in, but it's being used in all kinds of other places that many people didn't appreciate. It's being used to prevent robocalls and spam phone calls. It's being used in applications by individual developers in ways that widely used, widely used. It's been really popular and used in a variety of different fashions, many of which we didn't even anticipate. And I also said it was well regarded. Well regarded, you say? These are all real quotes. Most of them pulled from Twitter. I dropped the names from them because I don't know. And many of them are from very knowledgeable, very reputable people in information security. These aren't just jagoffs criticizing from nothing. Can I say that? I don't know. So some of these criticisms are pretty biting. I'm not sure they're entirely all fair, but they're out there and they're being made by legitimate, reputable people. This is very not hot. Taking some of those angry words, trying to distill those criticisms into what's actually behind them, what's the meaning of them, what's the cause, or what are they actually saying besides this sucks, or some of the other colorful language. So I tried to distill some of those. As I say here, badly, but I tried to distill. And one of them, probably one of the main problems, is you have to process the thing to know how to process the thing. And what I mean by that is all the metadata about what algorithm it is, even what kind of thing it is, what key to use to verify it, is all contained inside the encoded header. And you have to access that data and rely on some of it before you've had the opportunity to actually validate it. So it's a little bit of a chicken and egg thing, but it enables attackers to craft that header data, control that header data, and have the receiver at least partially act on it before any sort of cryptographic verification has been done on the object. And this has been at least partially the source of a number of the problems we've had. There's this growing trend in general that algorithm agility is bad. Now, you do kind of need something, and many of the same people that are saying it's bad are also probably taking advantage of the fact that algorithm agility exists to plug in their new favorite algorithms later. So you really can't get away entirely from algorithm agility, but the way that it was done in Jose really could have been better. What happens is, because there's an explicit declaration of the algorithm to be used, and because you have to process the thing to know how to process the thing, you give an attacker the ability to explicitly declare in the message to be processed what algorithm to use. And unless there's additional checks or opportunity on the receiver side validating what that is, there's nothing inherent to protect against that. And it gives us a whole window of attack vectors that allow the attacker to control, at least to some extent, the algorithm that's used to verify this thing. Another criticism is that different things are the same thing. This is true in that MAC is not really a signature. Signatures and MACs are similar in that they provide integrity of data, but they have a lot of different properties that don't line up as well. And the fact that they're the same thing together has allowed for the potential for some confusion between the two, which we'll see a little bit later. Nothing is definitely not a signature. Asymmetric and symmetric encryption are the same in that they encrypt things, but they're really different in the kind of properties that they actually provide and the guarantees that they provide about the message, who sent it, and the integrity thereof. Another criticism is that there's just too many options in these. Key identification and trust is hard. You saw all the different headers I listed out for identifying a key, finding a key, and determining whether you trust it. There's so many different algorithms. It's hard to know which one to choose. And in a lot of cases, it's a la carte algorithm selection left up to the deployer or the implementer to just choose from a menu of different algorithms and combine them in a way that many deployers may not be sure what they need to do or why. And there's potentially too many choices left up to the developer in the end. And all the claims are optional in JWT. There's good reason for this, I think, but in general, it's become problematic because it just pushes the burden of choice back down onto the developer, the deployer. There's not clear guidance or requirements around what is needed or optional, or required. Everything's optional, so it's up to the deployer to sort of profile it, or other standards to profile it on top of that. Some questionable options were also included. Some people really, this is RSA, old-fashioned RSA encryption has really been proven to be problematic. It was included originally for the sake of backwards compatibility with older systems and for systems that didn't have other support of other asymmetric encryption algorithms. But I think even at the time, OAAP was probably widely available enough that we could have gone without this. This one's been widely criticized. Some have also criticized the signature variant of the same thing. It's not clear to me that this is problematic. I haven't seen the kind of problems with it. It seems more theoretical, but some folks really dislike that it's there. AES GCM key encryption is super weird. GCM itself has a lot of really rough edges, sharp edges that are hard to get right. It made sense maybe as a content encryption algorithm, but it got sort of shoehorned into being a key encryption algorithm for JWT as well. Which is, it's just a really odd choice that was unnecessary, that probably didn't need to be there and just further complicates things by adding a lot of options that aren't very good. Alg none, of course, is more than a questionable option. It's an option that probably never should have been there at all. And there's a lot of other opinions too. Some of them boil down to like, it doesn't include my favorite algorithm, or some sort of crypto fanboy type people that are mad that their stuff's not in there. But yeah, opinions are like armpits. There's a lot of them, and they all stink. But there are a lot of other opinions that are criticizing. But in general, there are some, I think, some questionable options that were included, even if you step back and look at the reality of it. Some of these are somewhat questionable, and they sort of taint the perception of the whole suite. there's also this sort of meta-criticism that JWT is both so simple and but also hard, but simple enough that it gives people the liberty to go out and use it in a variety of ways. And that results in it being used in bad ways, or that the very virtue of it being easy to get your hands on encourages bad practices. One of those, people say anyway, is that stateless server authenticated sessions. A lot of people take all of their authenticated session that might have previously been stored, like in an HTTP session with a cookie associated data on the back end that represents the session. They take all that, stuff it into a JWT, and stream that back and forth with the client and a cookie, which I'll talk a little bit about more, but it's a really common pattern that has come under a bit of criticism. Public key crypto itself has some really sharp edges that a lot of folks don't know about if they're not cryptographers like myself. And there's been some criticism that the JWT suite sort of encourages the use of public key encryption, or public key cryptography, even in cases where it's not necessarily needed. HMAC keys with insufficient entropy, even though there's stuff in the standards itself that say to use long keys for HMAC, there's a lot of sites and sort of tutorials and things that use just short passwords for that. And an HMAC-based JWS with a short password can be fairly easily attacked offline with a brute force attack to recover that key, because there's nothing preventing that. It's a very high-speed operation. So if you're using a short password as your HMAC key, it's pretty much guaranteed to be broken and leaking that password. And the general, I wrote this, it's hard for me to say it out loud now that I read it. The general criticism that it's too simple and too complicated at the same time, and that in general people are stupid, which, I don't know, I sort of feel that myself sometime, but there's a lot of things that are made to seem almost too easy, like an HMAC signed JWS, while at the same time that makes it appear simple, easy to use, but there's all these other options and things that are sort of hidden traps along the way. Take a little bit closer look at some of the specifics that have come out of or resulted in some of those things. One, in general, I read somebody say that reading the archives and some of the old mailing lists, this isn't me saying it, but quoting somebody else, you find people raising many of these classes of concerns and being brushed off. And I think this is somewhat true. Not all of the things that have come out about JWT were sort of known beforehand and warned about, but a number of them were, and some of those criticisms were sort of brushed to the side or dismissed as the work went on. And I think there's a bit of lingering resentment as a result of this towards the standards themselves. There's this one that JWT is so popular that it has become synonymous with this concept of stateless authentication tokens. I mentioned this a little bit before. Really, I needed to include some sort of discussion about this here, but I have neither the time nor the competence to really give it sufficient treatment. You could write a whole book on it, so instead I decided to include a picture of a book, a long book. But encoding everything in a JWT has become a really popular approach for this. It's sometimes viewed as a panacea for scale and security for session management, because you can get a system that scales horizontally, linearly, because there's no back-end state being kept. All the state is coming between the client and the server. And that's really appealing for some, but there's a sense that maybe it's been overused. It itself is not a panacea. With that scale comes other drawbacks, including the inability to do logout effectively, revoke tokens, at least without a lot of other pieces in place. So it's not really a panacea. There's cases where it's probably okay, but it's being overused, I think, or likely overused. And there's definitely trade-offs between the two models, and I think the nuance of that has gotten lost in the conversation. People just want to use this method for stateless, scalable authentication sessions, and then there's been a lot of blowback and criticism towards that particular kind of usage. I would say that never doing that is probably saying it's too far, but the sentiment seems to have arisen, and there's backlash to the general popularity of this approach. For what it's worth, I did help design an access management product that does exactly this with stateless authentication tokens, and we've encountered some of the same issues. I still think it was a worthwhile design, but so that's where I go with the trade-offs, and I've been involved with, I guess, system design on both sides of this. Where are my keys? So a couple of the key identification headers, in particular JKU and X5U, are both the inclusion of a URL in the header of the object itself that tells the receiver to go resolve that URL to find the keys. And these are basically textbook vectors for server-side or receiver-side request forgery. You can trick a receiver into making arbitrary requests to a URL of the attacker's choosing, unless there are a lot of other constructs in place on the verification side to prevent doing that, in which case you've already exchanged a bunch of out-of-band information and you probably don't need to include the URL itself in the token. These are options that are probably rarely used in practice for meaningful things, and at the same time open up a wide variety of attack vectors that many people don't necessarily know about. Identifying the key or trusting the key. A valid signature itself is no good unless it's been signed with the right key. And one of the headers, JWK, is the raw key itself. And there have been a number of implementations that will accept a JWS with the public key to verify it in the header that says, I don't even know how to say it exactly. Basically, you're indicating the key untrusted that was used to verify it, and the signature over that doesn't tell you anything, but it was signed with the key that they told you it was signed with. Unless you also ensure that that's the key you're expecting from this particular entity, anybody can craft that kind of thing itself. And so back at an IETF meeting way back in Vancouver, I did try to say some things about this particular issue. And an email I wrote coming out of the meeting is, finding a key is not the same as trusting the key. And I'm concerned that this might lead to blindly trusting whatever key is found and enabling exactly that kind of attack. The writing I have here, you don't need to read, but it's a quote from the message above it. Is it weird to quote yourself? I don't know. But in retrospect, reading this again and going back through the archives, the effort I had here seemed really passive and almost resigned that nothing was going to change and nothing material came out of it. So then there's what I have now coined the MAC attack. This is an attack that's occurred because of algorithm agility, because of different things being the same, and because you have to process the header before actually processing the object. An HMAC signed JWS using the literal bytes of a public key can sometimes confuse the receiver into using that same public key as an HMAC secret key to verify the signature over the object. The public key obviously is not secret, so this is another area where anybody can forge a message just like this if the receiver is vulnerable to it and have a complete signature bypass attack. So I was actually contacted about my implementation by one of the guys that originally found this, and it was safe, except that it wasn't. So I responded to him. I tried to be polite, but I was a little bit smug about, I use an object-oriented language, and the safe typing and this and that will catch that attack. And I was a little more polite than that. But in general, I was a bit smug about it, responded to it. As a result, I did write a unit test to just kind of verify that that was the case and everything was all right. And not long after, I was doing some other work at an IETF meeting actually in Prague, and switched out the cryptographic security provider underneath that was being used. And it turns out it wasn't my code that was preventing this attack. It was the underlying provider that happened to prevent it. And the other provider that I was using that I plugged in was, in fact, vulnerable to this. So it turns out my smugness was not exactly right. It's since been fixed, but it illustrates the fact that there's opportunity for these sort of vulnerabilities to arise at the layers between abstractions and constructs, where you're calling into a library. If it's not providing you the things that you think it is, or that you assume it is, it opens up the opportunity for vulnerabilities due to mismatched assumptions, and that happened here. Then, of course, there's alg-none, where an unsigned JWS can confuse the receiver into treating it equivalent to a signed token. Very similar to the previous two attacks where it's a signature bypass attack, but in this case, you just strip off the signature, say this thing isn't signed, which is true, it's a fact. But if the library and the code accepting it sees that as a valid object, which it is a valid object, but treats it as equivalent to a signed object, you get a signature bypass attack, which can be really, really catastrophic. And despite many, many warnings in the RFCs, this happens all the time. It's happened so much that somebody even created a website for it that is, I can't read it because it's too long, it's how many days since the last alg equals none vulnerability. Although, when I pulled this up for this talk, it had actually been 122 days since the last time it happened, and it was actually a somewhat different vulnerability. So in some ways, I take this as a good sign that despite all the problems we've had with this, that the industry as a whole and libraries themselves are maturing such that this is becoming less of an actual problem. Regrets. I've had a few. Back to some old IETF communications around the development of this stuff. There was a process where a security area director at the IETF, one of the big bosses, said, hey, this alg-none, it's a really bad idea. What are you guys doing? Behind the scenes, there was a call to sort of rally the troops. I've redacted the person that actually made this call to protect their innocence. But some of us chimed in and responded with, it's fine. And here's the reasons why. And I wanted to help. I wanted to belong to this group that was developing this stuff, had code in production that was using alg-none in a safe way, but I didn't want to change that. And what I said in this message defending alg-none, it seemed very reasonable. It reads pretty well. It's a reasonable argument that makes sense, but it's also completely wrong because it ignored the fact of the realities of deployment, the mismatch of assumption between libraries and developers and what would really occur. All these things are reasonable things to say, but in reality, these warnings aren't enough. Similar to the warning here in London to look right when you cross the street, which is hard for some of Americans. alg-none itself has created the potential for this mistake to be made over and over again, despite all the fancy talk and all the warnings. It just hasn't been sufficient. And then along later came alg-none. Vittorio here doing his best impression of what I thought when I saw this. And I was very critical of this at the time, but doing a little research for this has given me a little bit of pause and trying to be a little bit gentler with some of these things. What was happening is there was a layer that was validating and protecting against alg-none and a layer that actually processed alg-none. And one of those layers was doing a case-insensitive check, and one of them wasn't. And by virtue of that, you could bypass it. It seems really silly, but it happened. And the pieces were in place from the standard itself that allowed that to happen because of even offering this as an option within the spec gives the opportunity for all these different libraries and deployments to make this very mistake. It's a silly mistake. It's a dumb mistake. But it should have never even been an option as a mistake to make in the first place. And then we get to math. Math is hard. It's particularly true with public key cryptography math. Neil Madden recently, sorry, I need to read my own notes here. Elliptic curve digital signal algorithms does indeed have some sharp edges that are not apparent to the casual user. There's a trivial signature forgery that came into play in Java recently by not checking some of the bounds on an equation. So if equation side evaluated to 0, then all signatures underneath that assumption would be considered valid. So Neil discovered a way to basically bypass all elliptic curve signatures in Java. It was pretty bad. It's since been fixed, but not good. Math is still hard. Elliptic curve Diffie-Hellman also has some really sharp edges. This one is a little bit older, but it was an attack on that ephemeral private key that I showed a bit earlier, where the sender includes their ephemeral private key as part of the key negotiation. If you include certain kind of keys that aren't actually on the curve that you're operating on, and you're smart and know a lot of math that I don't know, there's ways to do that a few different times with a few different keys and recover the key that's being used on the other side for the key exchange. So it's basically a private key recovery exploit attacking this because, or in cases where the ephemeral key that's being sent in isn't properly validated. Jose4j, my library, was one of the ones that was discovered on this. And Antonio, here, the discoverer of it, this is probably one of the worst messages you can get on Twitter. Hey, man, I get this from him a lot, actually, a lot of times, not a lot, occasionally. Usually, he's just saying something nice, but my heart sort of drops every time I see it. Turns out, I was speaking at RFSA conference when I was trying to address this, and messaging with Antonio after hours from the conference, struggling to understand just enough of the math to check for and prevent this particular problem. And this is a bit of dissonance that was more than just a little bit humbling. It was almost as humbling as my accommodations there at RSA. This was my hotel room. And speaking of humbly, this particular talk was rejected not once, but twice from RSA this year. I'll let you decide if that means this is your access to some very exclusive content or if you're getting some second-rate junk. Interesting one on JWT. You want to make sure those secrets are protected. So there's the potential here because a JWT includes the public key information, but it can also optionally include the private key information. It's nice to have a single container for that. But as JWTs themselves are most often used to share or publicize keys themselves, it can be really problematic if the private key portion of your stuff is accidentally published alongside the public key portion. So by inadvertently revealing secret or private key material is made possible by the structure of JWT itself. And my implementation was really conscious of this and tried really hard to prevent it. I had a nice little toggle switch on my JWT objects indicating whether a private key should be revealed or not. But it turns out I had it sort of, it's esoteric, but I had it at the object level, and under certain threading conditions, if one user of it was trying to deal with the private key, they had to switch it in order to turn it on to get access to the private key. And if a concurrent thread was reading that object to publish it, that flag was at the object level, not the particular operation level. So we had a sort of unanticipated concurrent usage caused problems, this very sort of problem where private keys were being published online. So despite even being aware of the possibility, there was still a key leakage info. It was very rare, we caught it quickly, but it happens. There's a better model for it now, but it was a learning that I went through going through this stuff. So now let's do some reflections, recommendations, et cetera. Trying to look back on this, reflections, recommendations, really probably mostly ramblings, but I'm going to try. So I envisioned a really eloquent and balanced appraisal of this whole situation, but you got this instead. There are, I think, as we've talked about here, some very legitimate security problems with the Jose and JWT implementations, and many of those themselves can be attributed to deficiencies in the standards themselves. Problems in the standards that laid the opportunity for these mistakes to be made that didn't necessarily have to be there in the first place. And some of those were very avoidable. We were warned, and we did them anyway. And some could have been done differently or better. The algorithm agility probably could have been done a lot better by tying the algorithm to the key rather than just having the algorithm itself be sort of independently stated. But these issues get fixed, and I think in some ways, more importantly, they get found because it's a widely used standard. There are researchers and people working on it that discover the vulnerabilities, discover the problems, report them, and as a result, get fixed. And some might view this whole thing as the whole standard being completely irredeemable, and anybody who thinks differently about that is morally and intellectually deficient. I've certainly heard some things along those lines. But you might also look at it as a pretty typical part of the life cycle of software or a software standard like Jose that ultimately strengthens the ecosystem overall. This fine fixed review cycle. And I think overall the ecosystem, the libraries that are available are maturing and are getting better. I also want to remember that 2010, 2014, when this stuff was being developed, was a long time ago. Improvement and simplification over the existing option at the time, it's hard to remember, but as bad as some of the problems in Jose are, the potential for problems in SAML, in XML digital signatures, was an order of magnitude more and worse. So this gives you some simplification, which is helpful. Broad support and cross-platform interoperability are oftentimes underappreciated. Some of the questionable algorithm choices that were included in there were included because they were available on a wide array of platforms, and there's some real value in that. Standards development is hard. Monday morning quarterbacking is easy. It's not an accusation against criticism, but it's hard when uninformed or disingenuous criticism is put into play. Most of the alternatives are different, or the same, or not really standards. A lot of them have the same problems, even though they purport to have them. Many of them aren't actually standards. And standards are just a social construct, although there's value in that construct. And everyone ultimately is trying to sell you something. Either me trying to sell you that this is not so bad, you can still use it, or the people criticizing oftentimes are trying to sell you their own implementation, consulting services around things, or just their own belonging into the in-group that doesn't like JWT. Some parting words for practicing safe JWT. One is consider abstinence. I'm actually a proponent. I like JWT. I use it. But there's a lot of cases where it's not actually the right solution. So think about it before you put it in place. Use a reputable implementation. It is relatively easy, but it's also really hard, and it's better to use somebody else's proven libraries. Use this stuff in a specific context or profile that appropriately constrains the options and ensure that those constraints are actually enforced. Like what kind of thing you expect. Acceptable algorithms, including disallowing none. Actually have that statically defined and configured in the system up front. How keys are found and trusted. And don't look at anything else involving that. Only look at the happy path of how you expect keys to be exchanged or understood. The set of required claims. Typically, you're going to need an expiration issue in an audience, but your mileage will vary. But this is a good place to start around which claims to require in your context. A type defined for the actual context or profile, which explicitly says this JWT is this kind of thing, and then all these other things fall out from that. But it's a nice explicit declaration thereof that you can enforce. And also do some testing. A lot of these mistakes seem really problematic and trivial, but a little bit of negative testing around the boundary conditions of ED cases can be really helpful and would catch a lot of the problems that we've seen come out later. And with that, I'm pretty sure I'm over time. I'm sorry, but thank you for coming for my motivational speech. I appreciate your all time today. Hope you have a nice rest of the conference.